Hello, hackers. Welcome. I'm Quinn from Major League Hacking. Today, we're going to be looking at how we can judge models and evaluate them and compare them using other models. This is called LLM-as-a-Judge. I'm really excited for this. I think it's going to be a really fun workshop. We're going to learn a little bit about how this methodology works. We're going to look at a paper, and then we're going to try and reproduce some of the results ourselves, have a little bit of think about the limitations, and then we're going to build a little Streamlit app if we have the time at the end. So it should be really good. I think we're going to do lots of learning. Hopefully we've got some people who are fans of learning and have done lots of learning this week. I know there's been tons of streams on, so let me know if you've had one which you've really loved so far. I'd love to hear about that. I'm going to give it maybe a minute or two for people to join in. I know sometimes the Twitch ads can be really long, so we'll give it some time. Hello, welcome. As always, I'm going to be monitoring the comments, so throw any questions out there, any little jokes. I love to see what you're all thinking about. As a heads up, I have your comments over here, and what I'm sharing, which I haven't shared yet, but will share, my screen is in front of me. So when I'm looking this way, and also looking this way, don't worry, I'm paying attention in both cases. It's good. But yeah, welcome everyone, welcome. As a little heads up, I'd really love it if you could check in. I popped the check-in link in the chat earlier. I'm going to send it again. Let me just throw that down. There we go. It's really valuable for us if you can check in, because it knows which streams you're going to, which streams you're really loving, which streams we should do more of. So definitely check in. And I think through checking in, you get points, and points are good because who doesn't love points? And I think you also get swag, right? If you check into 5 live streams, you get some bonus swag. So definitely make sure to do that. Awesome stuff. Well, I'm going to kind of gently get started. But we're going to take things nice and slow to begin with as people kind of join up. So I hope that's all good with you. I'm very excited for this. Let's get started. You get cool stickers. Oh yeah, cool stickers, my favorite thing. Okay, awesome. So like I said, we're going to be looking at LLM-as-a-Judge, and I'm just going to share my screen. There we go. So this is a paper. It's by many authors from a variety of universities, mostly out in the US. And this paper is called Judging LLM as a Judge with MT Bench and Chatbot Arena. And MT Bench, this is multi-turn bench, is a data set, and Chatbot Arena is also kind of a data set. It's actually like a leaderboard, and you can play this game yourself. Hopefully it will let me. I haven't done this in ages. But we could ask anything right now. We could say like, why is the sky blue? I hope this is going to work. I haven't actually tried this recently. And so the way this works is 2 models will respond, and then I will pick the one that I think is best. And so the way that this works is we do pairwise comparisons, and then these all get collated with a special algorithm. An algorithm that is similar to this is ELO. You've probably heard of ELO. It's used in chess. And we can see now we're getting 2 responses. And once I pick one, it will contribute to this data set and this ELO and so on. And I don't think they're actively using the data set anymore for this research, but originally they did, right? So anyone who partook in this and picked between different models and formed part of this data set went into this data set, which we could now use. I don't think we'll use Chatbot Arena today, but you could if you wanted to, and I'll give some guidance on that. We're going to be using MT Bench, but yeah, and now I can pick, right? Oh, actually there are new options here. This is fun. So let's have a little look. Sky is blue to a phenomenon called scattering. Yeah, this seems pretty helpful. It's step by step. Nitrogen and oxygen molecules. Okay. That seems sensible. This one seems really long. I'm going to be honest. This is much more succinct. So that's factoring into my decision here. And when we're building an LLM that judges between different models as well, we're going to be asking questions like, okay, is it influenced by the length of the answer. For example, that's called verbosity bias. So if it prefers longer answers, it has verbosity bias. And actually, the model that is used in this paper is GPT-4, and it turns out it does have verbosity bias of about 10 to 11%, if I remember correctly. So this is giving us basically a very similar breakdown. This is almost the same. It's traveling as like waves. Yeah, this is the same. Atmospheres full of molecules. We've got the scattering. I think this one is more comprehensive, actually. I think I like B. So let's pick this one. And I wonder if it tells us what model it is. It would be cool if it did. Oh yeah, okay, it does. So this is DeepSeek, and then this is Mistral. This is a much bigger model, if I remember correctly. This should be much bigger than Mistral. Or certainly it's generally ranked higher. So if we wanted to go to the leaderboard, I don't know if these leaderboards are the same now. Potentially not, actually. Oh, this is a mirror. Yeah, okay, so this is the same leaderboard. And if we check out, I mean, the model that we just had was DeepSeek R10528 versus Mistral Medium 2505. And we can see what we asked it really like a text question, right? So there we go. So DeepSeek is down here, joint 6, it looks like. And if we click view all, ooh, there we go, it's thinking. View all. We could look for Mistral. Mistral is down in 18th. Poor thing. Yeah, Mistral is not the most brilliant models, but you can see we've got these scores here, right? This is just like an ELO score. It might literally be ELO. I actually can't remember if they used ELO or not. There are a bunch of different algorithms which are similar to ELO with benefits and drawbacks. Yeah. And we can see here all of the different models that are available. Right down here at the bottom is whatever this is. Not actually too familiar. So it's a tiny model, basically. It's really, really small. We could run this on Colab. That's how small it is. Okay. So this was trained by Alpaca. If you've been to any of my previous streams, you probably heard me mention Alpaca a couple of times. This is a fine-tuning data set by Stanford, I think. Although actually, this might be a different Alpaca. Yeah, this is not Stanford's Alpaca. This is a different one. But it follows the same instruction input output format that I previously discussed. Again, if you haven't seen my previous streams, don't worry. I might mention them now and then, but they're not in any way needed for this. So basically, what we've got is a very simple, right, pairwise comparison of models, and you pick the best one, and then it adjusts the score a little bit. And also, it's really good, actually. It's got confidence intervals here. Many evaluations for models don't have confidence intervals, so that's not great. So this is the rough premise of Chatbot Arena. Excuse me, I'm going to sneeze. I think I'm good. I think I'm okay. Oh, I've got hay fever at the moment, but I don't have any windows open, so I'm not sure, what's happening. That explains their responses. Yes, it does. Yes, it does. Yes, exactly. And yeah, we could ask a bunch of questions for this. If you want to check this out, like, it's pretty cool. You could Google it like I did, but I'll send the link in the chat too. And you have a little play around with it. I think it's really interesting to see. And I don't know how well known this is or how popular it is, but I think it's a good little thing to try out to get a handle of how different models respond to things. So I do recommend it. Right. Okay, we'll leave it there with that. So let's look at this paper. So we've got this paper, and it's basically judging LLM as a judge. So they are doing what we're going to basically reproduce, which is, can we actually use LLM as a judge effectively? And it will say somewhere in here, but this is something that at this point in time was being looked at increasingly, and this is 2023. I think it was published in 2024 in ACM, which is a conference. And yeah, so their results, and I'm just going to highlight it here, show that actually strong LLM judges like GPT-4 can match both controlled and crowdsourced human preferences well, achieving over 80% agreement, the same level of agreement between humans. So MT Bench, by the way, is the controlled one. Crowdsourced is chatbot arena or the LLM arena that we've just had to play around with. And it's crowdsourced because, like, we could literally just go and do it right now. Anyone can. And so there's, an element of this. It's maybe more representative of people who are not necessarily like researchers. I imagine the people who were used for MT Bench were mostly like hand selected. Potentially they were experts in the kind of categories, and we'll talk about the categories in a second. But they were experts basically. Whereas the 30,000, which is massive, 30,000 conversations held on Chatbot Arena were just with humans. Now, you definitely also got an interesting thing to consider here. And if you're into research, you're probably already aware of this, but there's some selection bias going on, because the people who will go along and have heard of Chatbot Arena and will go and put in questions and try it out are much more likely to be technical people. They're much more likely to be studying computer science at a university. They're typically more likely to be academic in some way. And so there's some bias here, which is potentially a limitation, but generally, because they've got the two different approaches, this is like really high quality data as a whole. And it's very impressive. This was a very highly scored paper. You can check it out on Open Review and read some of the feedback from some of the reviewers if you're interested. But this is a really great paper. It's got thousands of citations, and it's a really, really foundational one in the field. It's basically the first paper which properly considered LLM-as-a-Judge rigorously. So this is really cool. It's fairly recent. I guess it's maybe 2 years old now, just under. But yeah, and so let's have a little look at MT Bench. This is multiple turn dialogue, right? And there are multiple ways that we could do the evaluation, and it will discuss it somewhere down here. Let me find it. Yes. Okay. So there are multiple different ways that we could evaluate different answers. The one that we just did was pairwise comparison, right? We're given, well, we provided a question, and then we get 2 answers, and we determine which one is better than the other. And you can do the same thing with an LLM judge. You give it a question, or maybe you get it to generate a question, but probably more likely we'll give it a question. Certainly in MT Bench, that's what we do. And then we have 2 answers, and we compare them, and we say which one is better. That gets us, a piece of data which we can use to produce some score. We could calculate win rates between different models. There's tons of things that we can do. We could also just get a single answer and grade it, or do the same thing but with a reference, kind of like a mark scheme that your professor might use at university or college or school. And so these are the 3 different types. I much prefer pairwise comparison. It's a little bit more rigorous because single answer grading, or even reference code grading, the point of reference is not necessarily consistent. And you have, for example, if you've got different judges, some might be harsher or some might be nicer than others. And so doing it on a stationary fixed scale is not necessarily going to be consistent or robust. So I think the pairwise comparison is the most convincing method, and we'll be looking at that primarily, and certainly I think most of this paper focuses on that. And so coming back to this, we're doing this pairwise comparison. We've got a question, and this is a multi-turn question. This one is actually about finance, and it says, if the Fed, so the Federal Reserve over in New York, buys bonds in the secondary market, and then there are a bunch of different options, and then we get 2 models to reply. And already you can kind of like, just briefly looking at this, you can see that B is looking better than A, right? B has replied with a specific one, whereas A has just said, well, it's said, okay, it's paraphrased A, so it's responded with the same thing. This is not a particularly convincing answer, right? We'd prefer it to answer like this, probably in a multiple choice kind of setting. So already we're thinking, okay, A is maybe not as good as B. And then we have a follow-up question, and this is the multi-turn format, and we're asking, how does it affect daily life? Give 3 examples. And the GPT-4 judgment on this is that it's repetitive. This answer from A is repetitive. It lacks clear examples. And reading through it, increasing the money supply, and lowering the discount rate, increasing the money supply and lowering the discount rate, and increasing the money supply. I mean, this is nonsensical, right? This is rubbish. This is a really bad answer. And B's, I mean, I haven't really read it, but like, it's obviously better than this, right? You can have a little look. It's got interest rates, inflation, employment. It's got some details. It's got, impacts on your life, how to make things more expensive. And so B's is definitely better. And this is the conclusion that GPT-4 comes to. And so in this case, we are agreeing, right? We have agreement. And the research of this paper is basically saying, well, if we use LLM judges, right? LLMs as judges to judge other models, do they tend to agree with people? Do they agree with people as much as people agree with other people? And this is a really interesting question to ask. And they go through all of the different methodology. One thing maybe to highlight is that they pointed out some biases here, and we'll talk about them later. Verbosity bias is something I've already mentioned. You might have a very valid thought, which is self-enhancement bias. If I've got a model like GPT-4 and it's comparing GPT-4's output and DeepSeek's output, which one is it going to prefer on average? And you might think, well, maybe I'm slightly cynical, maybe I'm slightly jaded, but I would prefer my own answer to someone else's on average, probably, as long as I kind of back myself, maybe, I don't know. But you might think you've got some bias towards yourself as a judge, right? This is why you can't judge yourself in a hackathon, right? That would be ridiculous because it would be unfair. Well, this is called self-enhancement bias, and it actually does exist. And if let's see whether they've got the stats somewhere here. Yeah, so GPT-4 favors itself with a 10% higher win rate. This is their findings. Claude version 1 favors itself with a 25% higher win rate. And so even though we don't tell the model which models it's judging, just like when we were on LLM Arena, right? When we were here, we weren't told which model. I mean, we could say, let's ask this. Let's do this. If we do this, right, for example, we've got assistant A and assistant B. We don't know which is which, right? But even with that hidden, ChatGPT, GPT-4 specifically, still favors itself 10% higher win rate. And this is basically because it's recognizing its own style of writing, right? So there's something about the way that it writes that it prefers from its own, internal thought processes, if you like, right? This is in quotation marks. Like, they don't have thought in the same way that we do. Certainly you've got reasoning models, but I don't think GPT-4 is. No. So, there's questions here. And I mean, this is going to be really interesting. We'll see which one. I mean, this is like judgeception now. We're judging models, judging themselves for the purpose of judging models. This is getting really confusing. So this is interesting. So it's not saying either one is better. This one is saying that, oh yeah, this one again. So they're fairly well balanced answers. I think this one has a nicer introduction than this one. I like how it's numbered things. And it's got a clear comparison. I think I prefer this one. I think both are okay, but I think I prefer this one. Okay, interesting. So this is Llama. This is Quen. Cool. Yeah, I don't actually know where these are ranked, but there you go. So like I said, we can't actually see which model we're judging, but certainly we might have a predisposition towards a certain writing style because of our own model internals, pretending that we are a model. And that could lead to self-enhancement bias, and indeed it does. We can see this through some nice statistics here. Could I share the link to the paper? Of course, that's my bad. Let me just pop that in here for you. And there we go. If you want the paper, it's this link here. It's up on the screen. It's in the chat on both YouTube and Twitch. Yeah, I do recommend giving this a full read through. We're going to probably move on fairly quickly now, but definitely give it a read. We are judging them, judging themselves, judging their judging. Yes, that is exactly what we are doing. It's getting so complicated now. Okay, cool. So there's a couple of other limitations. There's questions about reasoning and grading maths. And this again was a little bit some time ago where they didn't have reasoning models. We could try a reasoning model, and I think we should today. I haven't done it yet. I'm really excited to do it. And they've got some suggestions for, there we go. They've got chain of thought and reference guided judging. So this is kind of something potentially we're going to try out today. But they've got some some proposed even mitigations for these limitations. And so that's cool, right? So we've discussed what multi-turn judging is. Maybe it's worth mentioning, and I think I did mention it briefly. It's not here. There are 8 different categories. Yes, okay, let's go up here. So empty bench is the data set that we're going to be using. They had 8 different categories, and they are writing, role play, extraction, reasoning, math, cooking. Sorry, I'm going to say maths, and I probably will keep saying maths throughout this stream. That's because I speak British English, and the American English upsets me deeply to my core. No, I jest, but if you get confused by my British lingo, shout. I have definitely at points said things which people have gone like, what are you saying? I don't know what that means. It's pretty rare though. I think most British slang is fairly well known now. And then there are some knowledge questions, one for STEM, one for humanities and social sciences. And there are 10 multi-turn questions which are used. So we have 80 questions in total. And I think we have 2,400 responses from LLMs as a judge. And I think we've got 3,440 responses from humans. So we've basically got loads, and there's plenty of overlap, so we can calculate the agreement. I think we'll just dive into looking at the data soon, but basically their agreement stat, let's find it, is 85%, which is under setup S2 without a tie. I think setup S2 is just when they look at only turn one. When looking at 2 turns, I think it actually goes up. But we'll calculate all of these stats ourselves and go, oh, this is interesting. Let's see. Yeah, 2 setups. Okay, let's read them out. S1 includes non-tie and then tie and inconsistent votes and counts inconsistent as a tie. S2 includes only non-tie. So there we go. On the first turn, this is pretty good. So humans actually agree with themselves less than models do with humans, which seems slightly strange, but there you go. Perfect. And then if we check this out here, we can see that actually it's very similar stats on turn 2. So the turns don't seem to have a huge amount of impact. Maybe slightly lower, ever so slightly lower, with just a single judge. But yeah, okay. Oh well, sorry, not a single judge with single gradient. So the ones that we're going to be looking at is the paired judging. Because it's slightly easier to implement as well. So that's good. Right, okay, and this is all great. There's some discussions, there's some graphs, there's some tables. You can look at the comparison with other benchmarks. There are other benchmarks out there. You might ask, why do we even need to do this? Why don't we just run it on multiple choice tests? And you can do that. MMLU, which stands for Massive Multitask Language Understanding, does that. There are a whole bunch of them. Truthful QA analyzes how honest a model is, for example. There are loads of evaluations. There's also BLEU, spelled BLEU, which is an old NLP evaluation dataset, basically. But these are too rigid, too unscalable in lots of ways, right? And often multi-choice understanding is not representative of what we actually care about, which is how much do model outputs align with what we want as humans, right? And so this paper is saying, well, if what we care about is how good a response is to a human, why don't we see what the average human thinks about response, see if we can use a judge to essentially emulate that, right? And actually it turns out that we can. I've scrolled way too far. Turns out we can, because we get this level of agreement, which is super high, super good. And that means basically, yeah, if we use an LLM as a judge, hopefully it will be reflective of people. Now you could certainly ask, well, it might agree 85% across all of the different categories, but will it differ by category to a significant degree? And actually the answer is yes. This is something I've tried out, and I'm sure there's other papers which have looked at it, but I haven't found them. So there are flaws to this. They've mentioned some of them up here themselves, verbosity bias and so on. But let's actually get into it and talk through it. So what we're going to do is open up VS Code. Let me just catch up on some questions in the chat. Zoom in. Oh, my bad. It's a bit late now, isn't it, now that we're swapping? But I'll zoom in when I'm in VS Code. I always forget to do that. Okay, you're creating an application that judges and reviews your code base and provides feedback accordingly. That's really cool. That is really cool. Yeah, I mean, using LLMs as judges for that seems like a pragmatic thing to do, and we can talk about how it scores on the coding categories, in particular on Empty Bench. So let's get into it. Right, I think we've gone over most things. I'm just checking my notes to see if there's anything I missed. If there's any questions, let me know. We've discussed some weaknesses, some mitigations. I think we should kind of just jump into the coding side of things, right? So what I'm going to suggest is that you open up VS Code. I'm just doing that myself. Give me a minute. I'm moving so many tabs around. New window. Perfect. Okay, I've got VS Code open, and now what I want you to do is create a new folder. We're going to call it, I think I've already got LLM. We'll just call it LLM as a judge. Perfect, and we'll select for that. Okay, great. Now, hopefully this is all going to be stuff you're fairly familiar with. This is basically just going to be, as usual for me, a pretty typical Python project. If you do get confused by any of the commands or any of the little things that I'm doing at any point, let me know. But this is the terminal. I think you can activate it by doing this. Yes, you can. You can also do Control apostrophe on your keyboard. You can probably click New Terminal up here. It's got the shortcuts for you and things as well. And now I'm making a virtual environment, and I'm going to call it LLM-J, and I'm going to make it in a .vfv folder, which is pretty standard. This is what I normally do. This little bit here actually just changes the name of it in the terminal because I like it. I think it looks good. And then we can activate it. Now on my device, this is going to be a slightly unusual command because I'm on a Windows device using git bash. If you're using PowerShell, you don't need the source at the start, I think. And then that should work. So now we've got this active. We're also going to need a .env, and that's going to have our Google API key in because we're going to be using Gemini for some of the evaluation because we're actually going to run our own LLM judge, which I think is going to be really cool. So if you want to do that yourself, you could head along to aistudio.google.com/API key. The reason we are using Gemini, and I'm going to just send the link in chat for that. The reason we're using Gemini is because it gets us the most free access to models. Certainly we get free access to a reasoning model through the API, which is really good and unusual. If you head along to that link, which I've just popped in the chat, I'm going to bring it up onto my screen. You can log in with a Google account, and then you can head along to API key. Once you've done that, you can click this and copy it. I'm not going to do that on stream because it will probably pop up. I don't really want that, but I will do it off screen and pop it in here. So I'm actually going to just move both of these across to a different screen now, lest I share my API key publicly. You do not want to do that, and we will be trying to avoid that today. Great. Okay, and now I can move back. And what I've added while off screen is just a git ignore. You can do it like this, git ignore. I've already done it, so I'm not going to do it again. And what I would put in your git ignore, oh, we got some questions. Is it possible to use 2 image models, one generator such as Flux or StyleGAN and one discriminator? What I struggle with is that it's a bit hit and miss. 2 image models. So we're not actually looking at multimodal evaluation right now. We're just doing text evaluation. You could, I'm sure, do multimodal evaluation. I think your agreement rate will be much, much lower because the multimodal models are not as capable at the moment. This is not really my area of specialty. Certainly dealing with generators and discriminators, which is part of GANs. If people aren't familiar, there was a stream yesterday by Yash on it, which is really cool. Doesn't really come into it because we're not actually adjusting weights and things when we're using these models. They're already trained for us. So there's no element of training. We are not training, we are just evaluating. So I don't really think it's particularly relevant. You would like the discriminator model, which looks at the image to give you instructions to make it detect it as real. That would be really hard to do. That would be very hard to do. I couldn't tell you how to get started on that. There definitely are some AI image detection papers out there. I don't think they're very good. I think at one point Intel or maybe IBM, I think IBM, I'm not actually sure, had a model which they said was like state of the art, and then it turned out it didn't really work. And so basically this is like an open research area. If you can solve this, good job, but it's beyond 2 hours. Certainly it's probably much more looking at a PhD thesis if you're trying to build something like that, which is actually kind of better than anything we've got at the moment. And certainly I don't think anything that we've got at the moment is very good. So the bar is low, but also very high. So good luck with that. What we're going to do is we're going to quickly add get ignore and ignore our virtual environment and also our environment variables because we do not want to commit them. And on that note, let's initialize this. I'm going to initial setup, and we can see that we're not committing our other two bits and pieces, which is good. I'm going to make it public. If you want to check out this, you can head along to my profile. It's GitHub, and Augenblick is how it's spelled. That's actually a Dutch word, and I've horrendously mispronounced it, but it's easier to say it like that for English speakers to spell. It actually starts with a 0, not an O. So that's a little bit misleading. Right, okay, and then I think what we want to do is let's just make a experiment. We'll call it LLM-J experiment. And this is just going to be a notebook that we're going to use for all of our stuff. And we'll set it to this kernel. You can do that in VS Code really easily. You could also use Colab if you preferred. And before we really get started, we need to do some pip installs. So we've got some more questions in the chat. So I'm afraid I think this is probably not really relevant. Yeah, I'm afraid this is not really going to be relevant, and I'm going to kind of keep smoothly moving on, I think, because it's good for the weak models. Yeah, I think if you're looking at like, you know, if you're talking about GANs again, then I think I would recommend you go and like read up on some resources on GANs. You can rewatch Yash's stream, but like it's not really the focus of this stream, and I don't think anything that I'm doing is going to actually be relevant to that. So, but by all means, do stay tuned because we're going to do some really cool stuff this stream instead. What is the difference between this stream and the Gemini stream with me yesterday? Yesterday, we went through prompt engineering. This is something completely different. This is about how we can evaluate models using other LLMs. So yesterday, we did some automatic evaluation on an evaluation data set, but we weren't, it was multiple choice. It was a multiple choice data set. It was not dynamically evaluating longer form responses. So that is the difference. Yes, kind of they technically all fall in the evals, but yesterday we were really looking at automatic prompt generation. Today we're looking at how can we judge models with other models in a reliable way. Okay, so where are we at? I think we need to install some stuff. So the first thing that I want to install is pip install data sets. And if you do this, hopefully we will have a good time. All right, while it's doing that, and I recommend you do that too, I'm going to very quickly pull up a web page. So datasets is a library maintained by Hugging Face. If you've been to my previous streams, you know that Hugging Face is really useful. We can use it to load models. We can use it to load datasets. We're going to be using it to load this dataset. And if you want to find out some more details about the dataset that we're using, this is the URL. I will pop it in the chat. There we go. Cool. It's got a little bit of description about what it is, what it contains. Like I said earlier, we've got just over, I think, 3,500, well, just under, sorry, 3,500, so 3.3 thousand expert level human preferences between model responses. We've got 6 models, apparently. That's cool. Oh, there you go. Didn't know this off the top of my head. So these are the models that we've been looking at. This is with 80 different questions on different categories. Awesome stuff. Okay, and we're going to be loading this up, and we're going to do that by typing from datasets import load dataset, and then we're going to do ds equals load datasets. And this is pretty standard. If you aren't familiar with how to load a dataset from Hugging Face, head along to their website. It's huggingface.org, I believe, and read any of their guides. If you want to download a dataset, they provide code snippets for downloading that specific dataset as well. So if you get stuck with something specifically, it will help you out. And we're going to split this up into human and GPT for, I think this is the right data set. They've got a few different data sets, all of kind of the same empty bench. We want GPT-4 pairs specifically. They've got a few different data sets, and we will just double check that actually we've done this kind of okay. Oh, yeah, so we need to install this. I always forget this. You get a pop-up if you're using VS Code. If not, you can pip install IPyKernel, which just allows us to run a notebook. It's if you're using Jupyter Notebooks or similar. So we've got a little question about LLM-as-a-Judge. Yes, we critique one model. Well, we critique two models' outputs with one other model. We do not improve the responses. This is just for evaluation. And the purpose of this is to say, okay, can we actually use a judge to judge between two models and pick which one is best? And if we do, does it actually agree with what we as people think, right? Because you could do that with a random number generation, just swap between the two randomly, right? You could deterministically just pick A all the time or alternate or whatever. There's a bunch of things that you could do. Okay, this isn't good. We'll get to this in a second. Okay. Yeah, so that's the kind of rough premise. We're basically judging LLM as a judge. We're reproducing bits of the paper is essentially it. LLM Arena, yes. I mean, this is the paper which introduced LLM Arena. Yes, exactly. So that's the paper that I had up earlier. It was originally called Chatbot Arena, but now it's called LLM Arena. I recommend you check it out, the paper and the online little, I guess, game, if you want to call it that, which they use to generate the data set. Cool. So let's fix whatever problem we've got going on here. It's because I've added an E. Oh dear, British spelling. Okay, right. This is good. We've loaded it. We've got the human split. That's the number that we're expecting, 3,355. I got it wrong earlier. I thought it was 3,344. And then we've got 2,400 judged by the model. So we've got two data sets, right? We've split it up based on whether it was judged by people or by GPT-4. And using this, we can calculate how much we all agree, which is great. Let's actually print the column names. I think that would be good, just so you can get a handle on what they're actually called. Column names. Okay, cool. I've just reloaded the data set a bunch of times. I recommend doing your testing in another cell. I should have done that. So we got the question ID. Great. This is something we can use to match up our judgments. We've got the models A and B. We've got which one was the winner. We've got which judge we were using. We've got conversation A, conversation B, which turn it is. This is kind of confusing. Maybe let's actually check out the start of the data set. If we just do the first one row of data. Perfect. Okay, so the first question that we've got in the human split is question 81. Model A was Alpaca, model B was GPT 3.5 Turbo. The winner was model B, which is GPT 3.5 Turbo. The judge was author 2, and then we've got the different conversations. So this is the conversation that was had with model A, and it's got the question, it's got the first response, it's got the second question, it's got the second response, blah, 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 and so on and so on. And then we also have, oh no, actually, sorry, my bad here. This is just for turn 1, so it doesn't actually have the second response here. This is just turn 1. So I imagine if we just incremented this up, we should get turn 2 for the same question. Yes, there we go. So this is now in full with turn 2. Turn 2, yeah. So that's kind of roughly the format. You can see that we've got all of our responses. And this is great. This is fine. We've loaded the data. The data is good. We kind of hopefully understand the data. Yeah. Can I load this into, have I read the paper? Yes, I have read the paper. Yes, I do recommend you read the paper. How does it store the votes and evaluate? If a human votes, it stores them in a data set like this. This is what we just loaded. If human votes for one model over the other, will the losing model analyze the response of the winning model? No, no. It's just for evaluation. So we're not doing any model training. Could I load this into pretty JSON? I'm not going to do that right now. It's hard to read. That's okay. The only thing that you really need to know is what I kind of popped up earlier, which was this. We don't really actually care about the responses, to be honest. We mostly just care about which model has won and whether it agrees or not. So this is what you really need to know. And I don't think we need to load this into any other format. I think this is nice and clear that all of the text that's taken up here is basically just conversation A and conversation B. So loading it would just be like a whole load of conversations, and that's more or less it. So don't worry too much about that. Okay. Perfect. Cool. So I think what we want to do is actually calculate their stats, which they calculated, to see if we do actually agree that, okay, yeah, the humans and GPT-4 as a judge, let's see if we get the same level of agreement as them. So, oh, no, don't want that. There's a few other installs which we need to do. Let me just double check if I've missed any. So let's pip install SciPy and also NumPy. That should be pretty much it for now. So we'll let that run. Okay. So while that's installing, let's make a new code block. Perfect. Okay. Right. What we need to do is we've already loaded the data set, right? So we're good for that. We do want to import NumPy as MP. We didn't pip install pandas, did we? Oh, it seems to think we're fine. Okay, we'll just keep going. Cool. Right. So let me just move my tabs around very quickly. Give me just 1 minute. Okay, right, where are we at? Okay, so the first thing that we need to make is what's called a vote bag. And you can think of MT Bench as just basically a giant set of like competitions, like duels almost, where you've got one model against another model, right? And so for each duel, we have at least one human vote, which basically says which model ended up being better, which model ended up winning. And we've got at least one GPT-4 vote, right? This is, again, from the data set that we've just loaded. And to run any agreement calculation, we basically need a single place that answers this question. And the question is, show me all of the votes split according to the judge for this exact turn, question, and model combinations, i.e. this exact duel. Okay, and this is what we're going to call a vote bag. This is basically a nested Python dictionary, and it will have everything grouped by turn, question ID, model, A and B, and also the judge that was used. And so we're going to start writing this out. Hopefully we're going to get this working. This can be a little bit finicky because of the complexity of the different factors that we have to group by. So we're building a vote bag, which is, like I said, just this dictionary basically. And we will say, oh, actually, let's also first. This is going to make our life easier. Okay, so bag is going to be equal to no, okay. So it's just having a minor tantrum, but that's all right. Oh, lol, sorry. Let's get this right, shall we? I don't know. I thought I already typed this. I must have accidentally deleted it. I was like, what's going on here? Why is it not happy with me? Oh, I see. I've combined everything into one. So we're basically let's add a little nope. I hate when it does this. Yeah, we'll just call it that, right? That's fine. Okay, and so what we're going to do is going to go for row in rows. We're going to say the turn is equal to row turn, but we're actually going to -1 because currently the turn is change from one index to two index. Yeah, so currently it's one index, as we saw earlier. We've got turn 1 and turn 2, but actually it's probably easier for us if we have turn 0 and turn 1. Okay, and now we want to basically correct the model order so that we don't have any position bias, or at least as minimally as possible, that it affects our agreement rate. So if model B key equals row, row question ID, and then we want row model A, row model B. Yes, okay. And then the label is going to be just the winner, right? Row winner. Perfect. And then if it's the other way around, we're going to swap it like that. And so basically, that's not right. We do need to flip the winner. Oh, okay, we just accidentally ran that. That's not great. We do need to flip the winner, but we can't just do it by subtracting, unfortunately. So what we will say is, if the winner is model A, we will say it's model B, and if it is model B, we'll say it's model A, and then we will get the row winner, row winner. Okay, I think this should work. Oh, I think this should work. Okay, right. So now hopefully what we've got is we've got a key and a label, and the key has the combination of the question ID and the models being compared and the winner. And if the models are the same but flipped, it will still count and be amalgamated into the same kind of group, basically, right? And then we want to normalize the judge, and this is because sometimes the judge labels are slightly different. And so what we're going to do is we're going to run a function which I'm going to call canonical judge, and we're going to run it on the judge, and it's going to be upset because we haven't defined this, but that's okay. And then we're going to insert the vote into the bag, right? And this is going to be happening like this. I'm going to set default key. And if you were wondering where like some of the logic comes from for this, there's actually this is not exactly the same as the papers code, but they did publish the agreement code, so you can go check out theirs. This is heavily based on us to make sure that we got the right values, so the logic is fundamentally the same, though potentially slightly rephrased for clarity, just so that it's easier to teach. And so we now have this bag, right, which is basically just everything grouped up really nicely using dictionaries to do that, based on the combination of stuff that we have. And this is good. This is great. But we haven't actually defined canonical judge. So let's go and do that up here. And this is very simple. What we're basically just trying to say is yeah, if so maybe it's worth me going along to if we do just human split, and then we just do the first 10, and then if we do judge, this is going to work. I should have run this in there. Yeah, okay. Yeah, so let's do this in here actually. We'll rerun this and then not run this again, because I keep loading the data set and Hugging Face probably going to rate limit me again. That's happened. It's not good. Okay, so you can see that actually for all of the humans, we've got a bunch of different formats, right? It could start with author, it could start with expert. And this is what I mean by canonicalizing the judge. We're going to just change it to human. And we could also check with this. Let's check with this. Okay, these are all just GPT-4 pair. All of them will be this. We could do like 100 and it will all be the same. Whereas if we did human split, they're all going to start with author or expert, but they're going to have a different number, right? And I know this because I've looked at this data a lot. I'm pretty familiar with this data set, but just for clarity. So we're going to have to correct for that. So let's say if is instance judge list and judge naught is equal to GPT 4. So I think this is basically what we're going to do. This is just to correct in case, actually, sorry, I know I said that we're going to do it the other way around, but let's do it this way around. I think it's more sensible. In case anything is just listed as GPT-4, we will correct it to GPT-4 pair, which is what we had up here when we were checking out. I think they're all listed this already, but for the sake of being certain, we will run this just in case. But what we really are looking at, the main purpose of this is we care about this as a string. And this is also, by the way, if we got it as like formatted as a list or whatever, this is correcting for that too. And judge dot starts with, and then it starts with either expert or author. Then what we want is actually, we want it to be human. So we'll just say human. And otherwise, we'll just return judge. This will be the case where it is already GPT-4 pair. And so this looks good. This looks good to me. I hope it looks good to you. Potentially, we also need, in a similar kind of line of reasoning, in case, I'm just going to call this fold tie. If the tie, so sometimes models can tie, right? They're not always A or B. It could be a tie. If tie is in V else V. So basically, if in our outcome we have tie in there somewhere, then we'll go for tie. We'll just kind of assume, right? Right. Okay, perfect. Cool. Okay, let me just double check my notes once more. I want to make sure that I'm not just leading everyone astray. Wildly astray, that would be terrible, wouldn't it? Okay, so I'm scrolling about my code. My code is so long now. Okay, so we have canonical judge. We've got the vote bag that we built. This is pretty good, right? So basically what we need to do is we want to check if we actually have agreement on the terms, and we will check, we'll put in bag turn, which is going to be explained shortly, do not worry. And then we will have judge A, and then we'll have judge B. We could set some defaults for these. I probably won't. I don't think we need to right now. Actually, no, I think we're okay. And then we will say drop ties. And this is because in the paper, they do not always, just move my tabs back again. There you go, I'm faffing so much. Well, we've got some questions popping up. Let's check it out. I maybe will leave some of these for the end, and I think some of them are going to get covered as we go. We will use Gemini later. I know there's some questions about Gemini. We're going to use Gemini as a judge, but not yet. So that'll come later, don't worry. I have two monitors, one here, one here. I would love to have a third one. That would be super useful. Maybe like up here, that would be great, but we'll see. Yeah, we can use matplotlib. Yep, you can also use Grok. Grok is like probably, I reckon, one of the better alternatives if you're not going to be using Gemini, but I don't think we'll have time for that today. Yeah, we can do that. We will do that later. Yes, exactly. So author and expert, this just means This is just like the different type of human judge that they used in the paper. And if you want more detail on their methodology, I recommend you read it, but it's not really the focus today. We're basically just going to assume that this is the ground truth, that this is like roughly correct, or at least, good enough. And that's kind of what the agreement is going to try and measure. Okay, and so this is going to return. This is going to return the agreement and total votes for a given turn. And this is basically taken exactly from the code, which I mentioned earlier, but let's talk through it. Okay, so first of all, we'll have the agreement, which is equal to the total, which is equal to 0. We're just going to initialize these, and then we will say for the votes in bag turn dot values, if judge A is not in votes or judge B not in votes, continue. And this is basically because we need both the human and the GPT-4 pair judges to have voted for us to be able to compute agreement. Without one or the other, we cannot compute group. We need both. And then we will have the vote for A, and we will call this VA, and we will just run this, and then it's votes judge A, and it's going to be perfect. Okay. And then we will say if drop ties and vote A is equal to a tie, then we're obviously going to drop it, right? So we'll just continue. And then let's say for vote B in votes judge B. The reason that we only need this, by the way, is because the LLM is only going to give one vote. The humans might have voted on this many times. Indeed, we've got more responses from humans, so that's much more likely. It also means that we can calculate agreement between humans, which is interesting to us. And so we can say, let's set VB equal to fold tie VB. And oh, it's done some code for us here. It's not actually what I want yet. If drop ties and VB equals tie, continue. And then we will say total, and we'll add 1. And then we will say agreement. This is just a slightly smoother way of doing the if statement, but you could equally just or use an if statement. But this is basically the same thing. It's just a cheeky one-liner. Okay, and then perfect. So we need to get our indentation right, and hopefully this is correct. And then perfect. So for a row, or sorry, for a turn, we have nicely worked out how much agreement out of the total that we have. Okay, right, perfect. Great. Okay, so let's check what we've got. So we've got a human split, we've got a GPT-4 split, we can build our vote bag. I think we're kind of basically there. So let's give this a go. Right, so let's have a think. Right, bag equals build a vote bag, and we've already split up the data set. And remember that we need in this function, we want probably the human split, and then we probably, it would be good if I could spell it. And then we want the GPT-4 split. And is there anything else that we need? Nope, that's the full function. Okay, nice and easy. And then what we'll say is for turn in 0, 1, because remember there are 2 turns and we can check agreement for either. For tie in false, true. Oh, and it's predicted all of this for us. This is good. Agree and total, which is the outputs from our function up here for agree turn, is going to be bag for each of those turns. And we're putting in the GPT-4 and human pair. This is actually the wrong way round, so it's a good thing that we checked this code. As always, remember that AI is not infallible, it will make mistakes. And then we can print, yeah, I don't actually like this print statement very much. I'm going to rewrite it. I'm nice and fuzzy like that. So we're going to say agreement, and then we will say tie, and this is just a boolean as to whether we're using it as tie or not. And it's actually not tie because we flipped it. This is in here, it's whether we're dropping ties or not. So this should actually be drop tie. So I reversed it there, and then turn is going to be equal to turn plus 1, because remember we zero indexed it, so let's revert that, and then we can have agree over total, and then we will say, yeah, perfect, that's good. Okay, right, so now if we run this, we're going to get an error. It takes one positional argument, but two were given. Oh dear. Oh dear. Oh, Oh, I know what I've done. This is my bad. So we could actually just use the raw data set here, I think, but let's just do that. Oh, no, okay. We need this as a list. Currently, we've got it in the wrong format. And this is how it will work. Nope. Oh, okay. I thought we corrected that. So remember, we were speaking about flipping the label. Where is that? '19. Else key. Oh, we haven't run this again. Lol. It would be good if we actually ran our code. There we go. Mr. Code on out as well. Perfect. This time I have high hopes. Okay. So we're having some little tricksy time. Let's have a little think. So we've got some errors here. Somewhere, somehow. Okay, well, let's work our way through again from the top. So this is definitely right, I think. Let's check it all over. So if is instant, judge list and judge, and yeah, so we're restructuring all of this. We're pretty happy with this. Turn tie if tie in V else V. Yeah, that's fine. So build a bag of votes. Right, let's double check this then. So we're creating our, excuse me, yawning away. We're creating our dictionary. It's not even that early in the UK. It's midday right now, so it's there's no excuse to be yawning. So for the row in rows, turn is row minus. Yep. So we're zero indexing the turn. We are checking if our models are already ordered, and if not, we're flipping them, keeping the question ID, model A, model B. We're checking out the label, i.e. the winner. And then Is this correct? This is exactly the same, but flipped. That's good. I think that's correct too. We're cleaning out the judge descriptions. We're setting some defaults. The bag is constructed. The bag looks good. For votes in bag turn.values, if judge A not in votes or judge B not in votes, continue. I wonder if we might be having this problem where we're just you know what? I think I know what it is. No, okay. Worth a try. Yeah, no, I think that was right. Fine. Okay. Well, that's not magically fixed it, has it? Okay. Okay, so judge A is our is our GPT model. And we're going to just check for ties. If drop ties and the A is equal to tie, continue. For each of the human votes, we will check for ties again, basically, otherwise continue. I kind of think this is all correct. Maybe it's to do with how we're loading in our data. Let's try raw is equal to, so let's do this from scratch. We don't actually need that. And then let's build our bag. Build vote bag. List. I think list raw should just work here. Okay, that's interesting. Don't worry, we've got plenty of time to get through this. Okay, let's I actually don't. We've got some bug. We've got some tiny bug somewhere. Okay, let's go through once more and double check everything. Right, I'm going to paste in from my notes because I got this working and I think we've written it out exactly the same. If it's instance. Okay, I think that's fine, right? Cool. Folded tie, that's the same. What's the issue? What is the issue? Let's see if that makes a difference. It probably shouldn't. No, okay, right. Okay, let's try. So I'm just copying and pasting in functions that I know work. Okay, interesting. So did I run that? Yeah, okay. So I don't think it's the way that we've constructed the bag either. No. Is it the way that we've written agree term then? Seems like it must be. This makes no sense. Okay, this makes absolutely no sense. So what we're going to do. Okay. So this is what we should get, right? Okay, we're going to go through line by line. We're going to go through line by line and check that what we've got is right. Once more. If anyone's spotted what I've got wrong here, let me know. Hi to everyone who's joining, by the way. Welcome. We're debugging at the moment. We've got some issues. I'm going to actually just minimize this terminal because it's huge right now. Okay, right. So let's have a little look. Canonical judge. We take in the judge. We say if the judge is a list and it exists, and the first thing is GPT-4, make sure it's GPT-4 pair. Perfect. If the judge is a string and it starts with expert or author, return human. Otherwise, just return the judge. Perfect. Okay. Fold the tie. This is correcting for where we've got mislabeled stuff. Return tie if the tie is in the vote. Otherwise, return the vote. That's definitely right. Okay. Let's build the vote bag. We create a dictionary for each turn. Turn 1, turn 2. For each row in all of the rows that we have, we take the turn and we zero index it. Then, if model A is so we're basically just ordering things so that they're consistent. The key is formed of the question ID and the model A and the model B. And the label is the winner. Otherwise, the key is label A, label B. Sets to label A. Then we fix our judge label and we set our bag turn using all of the stuff that we've just made, and we return our bag once we've gone through all of the rows. Okay, that seems right. Okay, here's what I'm going to do. I think all of our code is pretty much correct. I think we're just probably passing something in badly. So I'm gonna, this is the code that definitely works, right? You know what, I think our code is correct. Yes, okay. So our code is correct. Everything that we just coded up is correct. All of our functions are correct. This is wrong. Yes, this is wrong. Okay. It's some really dumb error then. Agree and total are equal to wait. Is our print statement wrong? Is it literally just our print statement? I think it's, That would be crazy. If it's just our print statement, that is nuts. Print statements have never failed me before. Okay, we are dividing by 0. Fine. Agree turn, bag turn. That's identical. What am I missing? What am I missing? Surely someone has spotted it. It must be here. It must be here. Agree turn. This does not make sense. Wait. Wait. We run it now. Division by 0. We run it now. Still division by 0. What? Oh, we haven't got total M. Let me fix that. How does that make sense? Someone explain. Am I missing something really obvious? The only thing that's changed between these two is what we're calling the total variable, right? Oh, let's fix that. Okay. Wait. Oh. No. Okay. Has anyone else spotted the problem? I've spotted the problem. No. We just spent 20 minutes debugging what was literally just an underscore. Oh dear. My monster's flying about now. This is good. Okay. Don't know if you can also me. Oh my gosh. Okay. That's incredible. That is incredible. Okay. So all of our code worked. We are really just that good. And we can instead of doing this, we can actually just do human split and GPT-4 split. Actually, I'm pretty sure that we could just do this. This should just be happy, right? No, okay, it's not. Okay, this is fine. This is fine. Oh yeah, because we need to break it out. That's fine. Yeah. Okay, cool. So good. So we have working code now. This is great. Let's commit this. Reproduce agreement calculations. Perfect. And yeah, we'll sync the changes. So if you want to check out my code, if you're joining recently or you haven't managed to keep up, or you were also confused by my tiny little annoying bug, that's okay. I'm going to link my GitHub now. And if you head along to LLM-as-a-Judge, it doesn't have a readme. Let's add a readme quickly. LLM as a judge investigating reliability. Commit changes, create readme. Perfect. Okay. Great. Perfect. Okay, right. Now I have just sent the GitHub link in the chat. You can check this out. It's thinking that I've just made a change, but I haven't. That's fine. Yeah. Cool. Okay, cool. I will just sync us so that we have, yeah, the README. Nice. Still thinks we made a change. We haven't. That's fine. Probably deleted a space or something while I wasn't paying attention. Okay, so this is great. Right. So I'm going to add a little markdown. Recreate agreement calculation. So we've got these stats, right? And this basically says, okay, interesting. This data set says, actually, the agreement is 85.31% and 85.94%, or 66 and 65, right? Depending on whether we include ties or not. I noticed there was a question about why do we give it the tie option and not force it to select one or the other. I mean, if two models gave like almost identical outputs, you don't want to ruin your scoring if they are, you know, of similar quality, or even in some of the maths questions, they might both give the correct answer, right? And then it's like, well, you know, they're both right. This is fine. Yeah, generally, sometimes it's pretty pointless to pick between two models if they have basically identical or literally identical performance. That's my intuition for it. So we've got this, and let's look at these side by side. And we had that table earlier, didn't we? Let's go and see if the numbers that we've got are correct, or even if their numbers are correct, right? So interesting. So what did it say? So S1 includes ties and non-ties, and perfect. Okay, so how often does G for pair agree with humans when there are ties included? Ties are true. So we got it as 66.61%. They got it as 66%. Great. How about when ties aren't true on term one? We got 84.94%. 85.94%, sorry, they got 85%. Great. What about turn two? 65.73%. So again, look at G4 pair. This is the pairwise comparison. And again, 65.73%. That rounds up to 66%. Fine, we're happy with that. And let's check the final one, 85.31%, 85%. So really, really cool. We've actually reproduced these results from the paper using the data that they had, which is, I think, really awesome and a great achievement for us to have reached. So I hope we're all feeling like we've hit a major milestone, because I believe we have. Cool. So now I'll give us a brief pause for any questions. Will we prompt the author at all, like tell it to act like an author or act like an expert? We can get to using an LLM literally as a judge ourselves, implementing that ourselves in a bit. I think we'll have time. It's potentially a bit tight, but we should be okay. So one thing that I would like to do is maybe we could bootstrap our calculations here and actually produce a confidence interval for what we think the agreement is going to be like. And so that's an interesting thing that we can do. If you've not heard of bootstrapping before, it's basically when you resample all of your data and just take the average each time, basically. And doing that, we can get a different... Now I'm in a markdown file, aren't I? Okay, let's get rid of that. We will just do this. Okay, and in doing that, we can get the kind of confidence interval, right? The kind of almost the probability, not exactly the probability, but almost a probability of where exactly we will think these percentages should fall, right? And so we're going to create a function called proportion agree, and we'll say J1, J2, ban equals tie, and then we'll say n resample. So this is the number of times that we're resampling. So like I said, bootstrapping is just resampling a whole bunch of times. We'll do it 10,000 times. You could probably do it more if you wanted. You could do it less if you wanted. It kind of depends on how much time you have and how bored you get. Now, just thinking actually what the easiest way of doing this with the code that we've got is, let me swap to my notes and double check, because otherwise this could get slightly complicated. Perfect. Okay, so actually, I'm going to restructure this slightly. And we're going to just put in the bag term. And we're going to have judge A and judge B, which is kind of what we've done before. And we're going to say, as before, n equals 10,000. And okay, right. And now, what we're trying to return is the actual, okay, it's kind of already working out for us, spoilers alert. But what we want is we want the bootstrap estimate of the proportion of agreement, but using that we can actually get a confidence interval, so we can get a lower bound and an upper bound, wherein 95% of our resamples, that is something which it adheres to. And this confidence interval is something which basically says, okay, we can be pretty confident that it's in this range, right? And so we will say agree and total is equal to agree return. And does that look fine? Yep. And then we want to say hits are going to be, I'm going to use numpy, and we're going to concatenate np.ones, and this is where we get the total minus agree, and then that's all we need for that actually. And so confidence interval is going to be bootstrap. Bootstrap, and fortunately lots of this kind of statistical work is abstracted away from us using this package that we're using. We pip installed it earlier. If you didn't manage to do that, I recommend you do it now. And this is all basically just going to be some nasty nasty little bits of Python to manipulate everything to get us the right information. And so you can check out this function online if you Google it. The docs I think are pretty good for this. We have already set the yep. Okay, and so we want to get out the confidence interval. This is this thing which I've been speaking about. And so we will return the hits.mean, and then confidence interval low, confidence interval high, and then we can run this. So let's just do it. Let's just do agree. Yeah, so we'll just do it for turn 1 this time. You could adapt this again using these loops that we did earlier. And so if we run this, hopefully, fingers crossed, it might take a little bit of time. Probably not too long though. We will get out. Yeah, nice. Okay. This doesn't look right. Doesn't look right to me. Shouldn't look right to you. Oh, I see what I did. I've just been looking at it. We've concatenated nothing. Okay, so we need NP zeros. And this actually is the wrong way around. So let's correct that. We want agree, we want total minus agree. Perfect. Okay, now, yes, perfect. Okay, so you see this number up here. This is the number that we got earlier. This is the kind of big stat which they talk about in the paper, which is that on a single question where we ignore ties, humans and LLMs agree 85% of the time, roughly. And we've actually just calculated a confidence interval. So we can say that in 95% of samples taken, this we are confident that this agreement level will be between 83.87% and 88.02%. So we're basically very confident that it's going to be above 80%, right? We're very confident it's going to be above 83%, really. And this is really, really good, right? So we've got, not only do we have some stats, but we've actually got, okay, actually, we've got a fairly narrow confidence interval. That means that we're pretty sure that our estimate here is more reliable. So I'll commit this, added CI calculation. CI is just standing for confidence interval. We used it a couple of times here. So I think there's a lot of interest in the chat for actually deploying an actual LLM judge ourselves. So let's do that. Let's do that indeed. Right. And to do so, we are going to make a new file. And this file is going to be called, we'll call it Gemini Judge. I like that. Gemini Judge. And we need a .py here. Okay, and so we're going to be using a bunch of the functions that we've already used to calculate win rates and things, but first we need to do a whole load of imports. So we're going to import OS, we're going to import JSON, we're going to import time, we're going to import, actually we don't even need that, we're going to import random, we're going to import lib, import lib. So these are all things that you should have by default. This is standard Python stuff. Import default dictionary, which is what we use to build our vote bag. We can import dictionary and tuple. This is going to make our lives easier as well. We want NumPy, and we want pandas, and we want Streamlets, because we're going to be using Streamlit for our visualization. We haven't actually installed Streamlit yet, so let's do that. Pip install Streamlit. Now, if you know me, I basically only use Streamlit for my front ends. I don't like doing front end very much. You could very well build a better front end than this. It might take you a bit longer. Streamlit is nice and quick. That is the benefit. This actually is, like, transparently not going to be the most beautiful thing in the world. We don't have a ton of time to make it pretty, but that's okay. It's going to be functional, and we love that. So, right. Cool. And we also need some other bits and pieces. So we need from datasets import load dataset. We need from scipy.stats import bootstrap. This is what we just used to make the confidence interval. We're going to import google.generative.ai as GenAI. It doesn't like this because we haven't installed it. I think it's just pip install. I'm actually not 100% confident. No, that is fine. Yeah. Okay, cool. Right, perfect. And let's define some constants. So we want our data set, and we're going to call it, this is actually our ID for our data set, and this is LLM-sys. Slash, and this is just literally just the ID that we've used before to load our data set from our Hugging Face, right? And then we can define the model that we're going to use. And right now, let's start with Gemini 2.0 Flash Lite. We could change it to a reasoning model later if we have time to run it. We will. Let's also cache our results, and this is going to be so that we don't have an awful time debugging if we end up with like everything turning out as a tie or something, right? That can happen, and we'll call it cache. Perfect, and then we will say cache directory dot make directory exist. So if it doesn't already exist, make a directory to store all of our cached files in, and we'll set a seed, and we will random.seed, yeah, perfect. Okay, so now we need our canonical judge. This is all just to build the win rate stuff again, so I think we'll just copy and paste this actually. We've already written this out, we're pretty happy with it. Let's just copy and paste it. We don't need these imports, we've already done them. So let's calculate agreement rates to judges a given term. Perfect. So that's just split up a little bit more. It's a bit nicer. Yeah. Okay. Fine. Right. And that's great. That's great. That's great. Okay. Let's GenAI judge setup and cache. Okay. So we'll define a function to set the path. Oh, not for now. We're okay. I don't want parents turning me off. And path lit.path. Yeah, that's fine. Okay, return. Yeah, let's see if this is correct. We will use hash key. If I imported all the stuff that we needed for this, I think I did. Okay, and then we will define Gemini votes. This is the most exciting bit. This is what I think everyone is really gunning for. String, and then we want answer A, which is going to be a string, and we want answer B, which is going to be a string. We want, oh no, it's not predicted that correctly, so we'll just keep going, and then we will want API key, which is going to be a string, and then we're going to output a string. Woo! Okay, right, and let's just say that our key is going to be the question, answer A, answer B. So this is kind of like probably fairly familiar with structure with the keys and things from before, and then we'll set our cache path, and if it exists, we will just return JSON.loads. We'll store the whole thing. We don't just want the winner. Okay, fine. And okay, perfect. And GenAI.configure. So now we're going to set up our model. This is probably pretty familiar. If you've done a workshop with me before, we've done this like a million times. API key, which again, we're just throwing in through the function up here as an argument. And then I think we're kind of happy. Actually, I don't think we need anything else when we're configuring it. We want to set our model, which is going to be model equals GenAI dot generative model. There we go. There we go. Okay, and now this is, I guess, what lots of questions have been about, which is what will our prompt be, and we can change this and try lots of different things. You are a fair judge. So if you went to my read question and 2 answers. So if you went to my prompt engineering workshop, we could actually optimize for agreement using this paradigm and using the algorithm that we came up with. And that would maybe be an interesting thing to do, right? We could produce a prompt that maybe optimizes for that agreement itself. And so this prompt is one that I've tried and tends to work pretty well. I'm pretty sure, I haven't actually checked what the prompt is used by. In fact, this might be the prompt from the paper. I can't actually remember. I wrote this a while ago. But yeah, I would recommend checking out the paper. They almost certainly will detail the prompt that they use. Like I said, I can't remember off the top of my head. And we will put in answer B. Okay, and that's fine. That's great. We don't want to strip it. Okay, so we've got our prompts now. Now let's do try, and then we'll try and generate some content. Out equals model dot generate text. No, actually, we won't generate content. Sorry. I don't think generate text works, although it does seem to be predicted all of the time, which seems, a little bit strange. And we'll set the temperature to 0. This just means that we'll get a deterministic response. So if we rerun it, we'll get the same thing. Max output tokens, no, don't need to do that. It should be fine. Okay, and then we will accept exception is E, and then we will we will vote equals tie. Now we could handle this slightly differently, but this basically means if we time out, we're just going to set everything to a tie. We just skip it essentially, because we're not including ties in our agreement rate anyway. Not the one that we care about. You could, if you wanted to. Like I said, there's lots of room for your own creativity and freedom of expression here. Your own opinions as to whether you think you should or should not include ties. Right, that's probably a debate that could be had. Yeah, let's do that. Okay, so now we've got hopefully we've got the decision out, and I'm just conscious of time, so I'm actually going to copy and paste in what we're going to have in the decision, and then I'll commit this, and you can all copy and paste it too. I'll probably commit actually after we finish this file. Actually, I don't know why I just did that. That's what we want. Okay, perfect. So we're basically just saying if it's model A and model B in decision, vote tie. If it's A, vote A. If it's B, vote B. Otherwise, vote tie. So basically, if it's not clear, vote tie. Otherwise, vote A or B. Pretty simple, and then we just cache it, right? This is cool. And now we want to build our Streamlit UI. Streamlit UI, and I am going to shamelessly copy and paste, I think, the rest of this Streamlit app, just because I am conscious of time, and there's one other thing that I really want to get to, and I want to make sure that we've got time to play around with this. So the first thing that I think I missed earlier is that we need to set a rate per limit. Sorry, a rate per minute limit. It's quite hard to say, isn't it? I'm going to set that as 30. So we have 30 requests per minute, basically. And then I'm going to paste in everything else, commit it, and talk through it as we go. So give me just 1 minute. I'm just doing some quick adjusting for all of the stuff that we need. I've written some things in slightly different ways, and I'm just correcting it so I don't confuse everyone when I paste this in. Okay, perfect. I think this is good. Right, let's paste this in, and we will fix some of the formatting in here. Okay, as we go through. So yeah, so here is our Streamlit UI. As you can see, I've already got, this is actually not version 3, this is just the version that we're using. And it's going to be really upset with those of these things, so I'm just going to change them. So we've got, so we don't have sad VS Code. VS Code gets so sad sometimes. Okay, yeah, it doesn't like when I copy and paste. I've got notes in Obsidian, and it just really doesn't like it. If anyone else uses Obsidian or anything else for their notes, let me know. Yeah, so let's get rid of these. We don't need these. Load data set. Right, we can actually maybe make this clearer as well in our Streamlit UI. Okay, and all of this should be good. So feel free to have a little look as I'm just editing, and then I'll talk us through it in 1 second. So I'm going to, again, just make that really clear. Message text is not defined. Interesting. Where is this? Gemini 2. Gemini. So what this means? It means I missed something. I have missed something. Okay, up here where we were putting in all of our agreement rate functions, let's make a new one very quickly. Actually, we maybe need a couple of new ones. Yeah. Actually, do we? Let me just double check. We don't. Okay, right. We need. Okay, so we need to define message text. It's going to be a message, which is going to be a dictionary. No, don't want that. And this is going to be a very simple one-liner. Sorry, Copilot, jumping ahead. Message.get value or message.get content. Okay. There we go. Right, fine. Perfect. Okay. So where are we? This is where I've called my functions slightly different things. We should still have time to run this. It can take a few minutes to run. Fair warning. So what we want here is we want, what do we call it again? Does anyone know? Big return. Yeah. Big return. And we actually are just going to call it Gemini and human. Okay, right. I'm kind of feeling optimistic about this now. Before I talk us through it, I'll maybe run it. Yeah, that's fine. Maybe useful caption. Okay, and then I'm going to display at the bottom. Okay, and we'll say the download. Sure. Right, fine. Okay, so I'm feeling good about this. Let's commit it. Initial Streamlit app for running Gemini as a judge. Cool. Okay, now if you want to check this out, you can go and check it out. It's committed up onto my GitHub. And let's give it a run. And we'll see what happens. If it runs, great, I'll come back. Sorry, we're going to Streamlit run, aren't we? Gemini underscore judge.py. If all is well, then I'll go back and talk about how the code works. If we have problems, we will deal with them as they come. Okay, it looks kind of like we've worked well. Okay, right, fine. So I'll talk through the code now. So first up, we create our little sidebar. This is all UI stuff. I won't get into too much detail. But what we're doing is we're loading the data set. We're grabbing the human rows, and we are doing a bit of cleaning. Perfect. And we're making sure that we're only getting out the rows which are for turn one. That's kind of the thing that we are most interested in now. If we can't find any eligible pairs for calculating our agreement on, because we need human pairs, then we are just checking for that. But like it says here, it's unlikely. It is fatal. It's true. I was clearly in a dramatic mood when I wrote this. Yeah, and then oh, I don't know why it doesn't like my Obsidian notes. So sad. And then we just do a judging loop, right? And this is pretty obvious. What we do though is we check for the rate limit and then pause, because otherwise we'll just get a whole load of ties. You remember up here where we check for exceptions, so we'd get an error if we hit the rate limit, and it will just vote ties for everything. We don't want that because it will drastically affect our rate, our agreement rate. So we'll give this a go. We loop through like as before. We're grabbing out all of the information that we need, and we're calculating the agreement, which comes next. That's down here. We build our vote bag once we've got all of our votes in through the judging loop. And again, we can calculate a confidence interval as long as we've got at least 2 pieces of data, which we should, right? Depending on how many times we run this. Let's correct these again. I don't know why it's just in a mood. It's just in a mood today. I don't think that's going to work either. We'll, perfect. Okay, right. I think this is looking good. So let's run it again now that I've made some corrections. And I will reload it and show you all. So I will Control-C out of this. Perfect. And then I'll run it again. So you can just do this with Streamlit, run Gemini Judge. Again, you should have basically the same code as me. It should be fine. And we will get a nice Streamlit page. Look at this. Look at this. Wow, how exciting. Okay. Now, we could run it on the full human data set. I would not do that. It would take forever. Bearing in mind, you can get 3 requests per minute. We're probably going to manage about, I don't know, 100 in a minute. So let's do 100. This is the lowest number that I've set. This is going to be our API key. Do not share this publicly. I'm going to paste mine in from my env, which I'm going to copy it off stream. I'm going to quickly just test. Yeah, so it's not showing, which is good. And it's going to apply it. Perfect. And then we can click run evaluation. That's pretty classic. I know what the issue is. In true fashion, I have typoed. I have typoed this again. This is, again, the British spelling. Now this is correct. I will rerun. And again, I'm going to copy our API key. Once this loads, we'll run it. Great. Enter. We've applied it. It's happy. Why? Why can it not be accessed? Okay, now this is no longer fun. This is no longer fun. We're tight on time. Are we going to make it work? Are we not? I don't know. I don't know. Let's check our experiment where we load the data. So this is what we should have. Is it what we have? No. Okay, that'll do it. We missed out the S on the end. I mean, I think we've made, what, 3 errors today, and all 3 of them have been like typos or misspelling. So that's probably a record. I don't think I've made this many typos in a stream. Not big ones that have held us up for so long. No way. So that's good, isn't it? Oh dear. Well, I hope you've all enjoyed this. As we can see, we have successfully loaded the data. We've loaded the splits. We're now evaluating. It's going to get up to 29. It's going to stop. It's going to pause for a minute because we don't want to hit the rate limit. And then we will rerun, and then it will start again in a minute. So this is why it takes some time, right? It's frustrating, right? If we had, if we're willing to pay for API credits, I don't know, running this would probably only cost like 50p or something. It would be pretty cheap. But for the sake of keeping this accessible, we're not going to use any billing information. So we'll just run it and see how it goes. I've got about 5 minutes left. In the meantime, let's check out Global Hack Week /schedule. And let's see what's up next. I'm super excited. Okay, so, oh yeah, of course, this is the last stream for today. And that's pretty cool because it means day 6 is next, which is super exciting. The next stream is actually going to be with me. It will be with me in about 4 hours, just over 4 hours. So head along to that. We'll be talking about everything that's happening in day 5, everything that's coming up in day 6. There's some mini events by the looks of things. We've got a cool looking workshop with, I don't know what this is. This is new to me, but Vapey? Vapey? I don't know what's that. But voice inputs. This might be Jocelyn. I think Jocelyn likes doing these kind of things. So, but we'll talk about this in today Global Hack Week in more detail. It's going to be really exciting. And then we've got Alberto, who's finishing off MCP Agents. This is a 2-part series. Carrie's finishing off the Ed Tech and AI educational learning tool, which she and hopefully you all are building, which sounds really exciting. And then we've got the closing ceremony to finish. So head along to those. It's going to be a really great time. Get your challenges in. You've got, I don't know, I guess 24 hours a day or so. So There's loads of time left. And that's super exciting. Let's see how long this is going to take to load. There's one other bit of the workshop which we haven't done. It's going to get stuck at 89, I think, and then we'll go again. So there is one other bit which I really like, and I might just copy and paste it in for demo purposes. It is the agreement rate according to the categories. And I think it's super interesting because obviously if you've got different agreement rates under different categories, it says something, right? I actually don't know if I've got the code anymore. I wrote it quite a while ago. There's also some other bits and pieces that we discussed. So for example, we can check the let me see if I can just be able to run these. Oh, actually, yeah, okay, here we go. No, no. Oh, this is because we changed the function. Okay, no. Okay, well, we can overrun. There's nothing after this. So if it's all good with you all, we will be a bit cheeky and we will overrun ever so slightly. Oh, let's not move that across. That's got my API key on. Oh, there we go. That was close call. Okay, perfect. Right. Where were we? So this is outputting just the agreement and the total. And the code that we put in was using an older version of this function, which was expecting flags. I can't remember actually what they were for, so let's go and check that out. I'm just looking through my notes. Yeah, let's have a look. Okay, let's work through this together because I think we rushed over some of this, so we'll go through it in more detail. So when we're doing the agreement, we are pulling out flags, and that's all we use it for, I think. So when we calculate bootstrap over here, we're using hits, which is just the concatenation. Okay, so flags is actually just going to be hits. This is what we renamed it to. And so let's ditch that, get rid of this, and then we'll replace this with this, this with this. And yeah, that looks good to me, actually. So let's just rerun it. Okay, let's also go to git ignore and ignore dot Gemini cache. And we'll delete it actually, because I mean, you can see that it's got all of our outputs here, right? Lots of ties, actually. I think that must have just been, no, that was just random. That's really crazy. Okay. Well, anyway, let's delete this now. We don't need it anymore. It will regenerate itself eventually. Okay, perfect. I'm actually going to close that so I don't click on it by accident on stream. This should work now. Let's rerun it. Cool. And yeah, we're going to overrun. That's my bad, but it gives us some more time to do some other exciting things. I'll give it till 5:10 past, so just so you know, that's how long we'll overrun by. Right, and again, I'm going to grab my API key, as you should also do, but do not share it. And it's going to do some loading for us. Hopefully everything's going to be good. So what I was talking about just now was two things: whether the agreement rate varies. We'll let that run in the background. Whether the agreement rate varies across categories. And so I have actually got some code pre-prepared for all this, which hopefully I can just drop in and it will work. Let's see. Now we're using where does this come from? Somewhere I've said what data is. Oh, okay, fine. Okay, so this is, when I previously ran this, I used a slightly different structure. Like I've said earlier, this is part of the reason we've got some slight kind of like quirks where I've been resolving things. This is actually just our bag. So what we want is we want bag, I think. What's bag's output? Yeah, we want bag. Okay, cool. We've also got votes equal. Don't know. I made that. Okay, this is actually just this is actually, we don't even need that. So what we're doing is we're just checking that the votes are the same, right? And we're using this tie function that we already wrote to deal with if we potentially have like weird tie stuff going on. Okay, and then, I mean, in theory, we've dropped it, right? We can calculate some stats. I think this should now work. I said that like with a lot of confidence. Okay, this is good. So we've got out the data according to the categories. We've got our p-value. We haven't. Okay, let's make a new terminal. That's still going, that's fine. So we will pip install matplotlib. I know there's someone excited about matplotlib. This is going to be a really ugly graph. I'm afraid I haven't focused on the visuals of this workshop, so apologies for those there. Glad to see people are excited to come to attend Global Hack Week later. Did I give Gemini an instruction prompt? Yes. So I did. Let's rerun this quickly. So the prompt that we used is here. I typed out, we say you're a fair judge, here's the question, here's the answers, respond with them online only. So pretty simple. Pretty simple, right? And then, cool, okay, so we can actually, this is really cool, this has worked. I'm glad that we managed to put this together. So I might actually just delete these comments because I don't actually think they're very helpful. Yeah, they're older comments, so they don't necessarily conform with what we've actually done here. Yeah, some of this code is like a little bit old, doesn't really match up, but it works, so it works. These are the stats that we should get out. So interestingly, we've got very different agreement rates depending on the category. Interestingly, maths is really high. I suspect this is because some of the maths questions are quite easy. In the paper, they note that maths and reasoning is what they kind of expected to be lower. So it's interesting that we kind of potentially disagreed with that. Writing seems to be more subjective, and it seems that there's just a lower level of agreement in general on this. What might be interesting to do is to run this again, but looking at specifically the agreement rate between people and see if that also varies across the categories. Could be an interesting extension. But without further ado, let's check out our results. So nice. Okay, so we've got our agreement rate between Gemini and a human. And we've got n is equal to 103. I don't think that's right, but never mind. I don't know how that's happened. This is something worth checking. But this is a pretty good agreement rate, right? It's lower than GPT-4. This is because we're using a really fast and small model. But it's pretty good, 70.87%. And we've got some confidence intervals. These are quite big. So we've got nearly 20, probably what was that? 17-ish, 17.5 percentage points in our confidence interval. That's quite big. So the reason it's so big is because we've only run it on 100 100 pieces of data. But even then, the fact that we know it's above 60%, not terrible, not terrible. If you were to rerun this, you could, and you would probably do it on a much bigger sample set. You could also use this exact code over here, and you could change the model type to the reasoning model, and you'd probably, I would expect, get a much higher reasoning rate. And that would be interesting to do. You would have to change the rate limit. I think, let me Google it for you all quickly. Rate limits, Gemini. So on the free tier, the rate limits on the most capable thinking model, which we have access to, are interesting. I'm not seeing the one I'm looking for. Okay, so we do actually have access. I think this is new. This must have updated very recently. So we've been using 2.0, but we could have been using this. What's the rate limit on that? That's interesting. 15. Okay, interesting. So we've been using this one. What I was looking for is the, I think just the, what we want is a reasoning model, right? I used one recently. Does anyone know the reasoning model off the top of your head? I think, yeah, I think the pro model will be higher for sure, 100% for sure. But I don't know if we get access to. No, we didn't get access to the pro model on the free tier at all. I think the most capable model that we seem to get access to now is, yeah, this updated literally yesterday, which is crazy. I think probably, yeah, this was yesterday's update. I think the one that I was using was deployed on the 20th of May, and we no longer have access to it, which is a bit unfortunate. It was a 2.5 model, so it was one of these, but yeah, we don't have access to it anymore. So probably, let's have a look at 2.5 text to speech. We want a reasoning model, don't we? Adaptive thinking, cost efficiency. That's kind of sad. I thought we still had access to a reasoning model. Let's just search reasoning. Okay. Oh, so 2.5 Flash can think. Okay. So yeah, if you wanted to, you could change it to 2.5 Flash. And let's try that now, right? So I'm not going to run it because it will take too long. But if you wanted to, you could change this to 2.5 Flash. And let's just double check we've got that correct. 2.5 Flash. Yeah, that's fine. So, and then we would want to change the rate limit on it to, what was it, 10. So this is going to be much slower to run. But if you wanted to run it, you could. And I'm going to commit all of this at the end of the session, so you can check out all of this code. You can run it all yourself. And this, again, would be completely free. You'd be able to see whether you get a higher agreement rate. And certainly, I think one of the most interesting things to do would be to increase this to maybe, increase it to maybe 500 and then run it on a more advanced model. Obviously, this doesn't update. I don't think it updates. I can't remember how I wrote it, but it might actually. Depending on whether we were smart and used this or not. I don't think I was smart, but we'll see. And so I'll actually maybe run this as I end the stream. But finally, I want to say a huge thank you for coming. Sorry for overrunning slightly. I will commit all the changes. Don't you worry. You can check this all out after the fact. There's some questions about research papers. How do you read such a paper? Have tried reading one. Attention is all you need. That's a classic paper, but it's hard. Have I ever written one? I've done some research. I haven't published any papers. I'm hoping to next year. I'm doing my master's. I think it comes with time and practice. Try and read a paper a day. This is something that I did for a bit. I haven't done it recently, but I'm going to get back to it over the summer. Read a paper a day. Read a few papers a day. There are so many papers coming out all the time. Just read them and you will kind of generally start to absorb things. What I would say is that some of these papers have quite high barriers to entry. This paper that we went through today didn't actually, it's kind of quite intuitive. But some papers have like really technically complicated ideas. And so if you aren't doing an undergraduate, if you haven't done an undergraduate degree, or you're not doing a degree, or whatever, you don't have academic teaching, you might find it extra hard. My recommendations would be if you look up courses online for deep learning, that's probably your best starting point for all of the stuff that I talk about. If you're looking at generative models, that's kind of the basics. But yeah, just I would say practice and getting a good grasp of the core concepts that you need, understanding actually, what is a neural network. These kind of things will go a long way. So that would be my recommendation. But with that, I will. You just watch my stream instead of reading papers on AI. I mean, yeah, you could do that too. I don't go through anywhere near all the papers. There's so many papers, so it's probably not going to get you a fully complete and conclusive and comprehensive understanding of papers. But yeah, join my streams. If people are really interested in research papers and going through research papers, I could definitely do a stream on this. And on that note, like, it's really valuable to have your feedback. I'm kind of super excited to see people chatting about what they're interested in the chat. So if you head along to mlh.link/GHW feedback, that link is now in the chat. I'm going to throw it up on the screen. You can give feedback. If you thought this was good, please let us know. If you had suggestions on things you want to see in the future or any improvements that could be made, I really value that. I want to make this the best experience for you as possible. So give us the feedback. It's really quick little survey to fill out. And I'd love to hear your thoughts. And yeah, if there's anything you'd like to see in the future, maybe more research papers, let me know. With that, I'm gonna run this and then pop myself off stream. And this is now not what we want. Let's go back to here. This is what we want. Okay, let's rerun this, and I'll end the stream probably with this just running in the background with some music on. You can chat if you like, but this is now the official end. Thank you all for coming. And of course, as promised, I will commit the code to as the stream ends. So yeah, I hope you have enjoyed. I hope you do continue to enjoy. And we will run this for 500. This is not actually flashlight anymore, but we'll run it anyway, and we'll see what we get. So thank you all for coming. It's been a wonderful time. Feel free to throw any questions in the Discord. I'll be floating around in the general chat, the GenAI week chat, the technical chat. You can ask any questions that you like. And thank you so much for coming. One final question before we go. Do I ever do any YOLO streams? Do you mean you only look once, the computer vision one? Because I've studied it, but I don't have much passion for computer vision personally. But I think actually Jocelyn has just done one last night, or at least last night in UK time. So I think that would have been fairly early morning IST, or fairly, kind of like early mid-evening. Probably early evening over in Eastern time. So yeah, if you want to check that out, I recommend it. It will be on YouTube. You can go and find it. So thank you all for coming. This is goodbye from me, and I will see you later. Happy hacking.